Engine Performance 1, Test 7. Got it? Technician A says the pulley on a centrifugal supercharger is larger than the crankshaft. Technician B says centrifugal superchargers are driven by exhaust gas.
Either one of them, they both do.
All right, neither one of them is right. Let me ask you this: if the pulley on a if the pulley on a supercharger is larger than the crankshaft pulley, what does that mean?
Not very much boost.
That means it's going to spin slower than the crank, right?
So it's going to put out less boost than what
It's going to put out less boost and all that, yeah. All right, so you got to, that was pretty cool if you ever see a supercharger sitting on a bench, like a blower.
Yep.
And you got this blower sitting on a bench and you lay some rags over it. And you grab the pulleys on that blower and you spin it backwards, it'll blow that rag off the top of it. I mean, just spin it with your fingers, it'll just blow that rag. It's really something how it grabs the air and moves
I
it.
don't understand how. I understand.
It doesn't look like it would, does it?
No,
It's just
I
these big curly. But it does. It actually moves the air. It's carefully. And also, here's something else. A lot of people don't know about superchargers. Those things can't touch each other.
Yeah, I know.
Ever. And so what you got to do is you got to shim these helical gears to make sure they don't make any contact at all.
Yep.
All right. All right. So that one's going to be a D, right? Which of the following is correct? The bypass valve opens in reverse gear. The bypass valve is closed during acceleration. Most manufacturer-equipped superchargers have a bypass valve to control boost. Or all of these are correct.
How do you control boost on a supercharger?
Well, you got a bypass valve. You haven't read the chapter? Got pictures and everything in there. Tells you all
I was
about it.
doing all this.
Why didn't you mean to explain it? What's in the book? What's up with that?
Do what?
You got a book for a reason, you know what I'm saying?
Well, I was asking
Can
you-
anybody explain that to
Never
him?
mind.
I don't know. I'm not giving you a hard time. Can you explain it to him? Somebody?
I was trying to ask you.
I don't know how how it works on a supercharger, but I know
Yeah.
how it works on a turbo.
That's
Yeah.
what I'm saying. That's
Basically the same way.
Yeah, so, I mean, can you explain it at all? I'm trying to get you guys to dig for information because what I tell you, you're going to forget.
How the bypass valve works on a supercharger?
Yeah. How does it control boost?
Through a vacuum?
Huh?
Through a vacuum?
Well, I mean, the vacuum is actually going to operate it.
Right.
But what does it do?
What does the bypass valve do?
What does the
Stop
bypass
the
valve do?
flow.
Write me a report about that. Paragraph. About 200 words.
200 words?
Yeah. So that we can understand it. Okay? Can you do that? I think everybody ought to do that. I need to know how it works.
this type of release valve routes through pressured air to the inlet side of the turbocharger for reuse. And it's
Instead of shoving it into the engine, it rechannels it.
right.
That ain't complicated. That's what I was trying to get you to say.
So
Okay?
it reuses it?
It just runs it back to the inlet.
Oh, okay.
Instead of shoving it into the cylinders, it runs it back to the inlet. That's what they call it, a bypass valve. It's not complicated, is it? All right. That's one of those things. If you read the chapter, you'd know the answer. That's the whole thing.
I read it the first day I got the book about
Yeah.
that.
All right. Now, technician A says supercharger. Actually, all of these are correct, by the way. The bypass valve opens in reverse gear. Why do you want boost in reverse gear?
No?
When a bypass valve is open, you don't have boost, right? When a bypass valve is closed during acceleration, you do want boost during acceleration. You know how often you're supposed to check the oil in your supercharger?
No?
It's a different kind of oil. It's separate oil. Got a little placer. Little place, screw a plug out. You look in there and check the oil. Supposed to check it every 30,000 miles.
30,000.
Yeah. Doesn't usually leak out of there. But a lot of times the belt that's driving the supercharger is a little wider than the regular belt. The pulley will, the bearings will foul up down there in one of the pulleys, outer pulleys, or maybe the tensioner, and the belt will come off of it, and the person driving the car won't even know. Won't have a clue. All right. Now then, technician A says superchargers are driven by the engine crankshaft.
Yes.
Technician B says superchargers use a synthetic oil inside the unit.
Yeah, I mean,
Is that both or neither or what?
both of them are right.
Both of those guys are right. That's what I'm talking about. It's separate oil in there. Okay. Technician A says turbochargers send high pressure exhaust into the combustion chamber. Technician B says turbochargers use a huh?
Either one of them.
Yeah. Technician B says turbochargers use a belt driven by the crankshaft. Does a turbocharger use a belt driven by the crankshaft?
Nope.
No. You know how that turbocharger, well, like on the old Super Coupe Thunderbirds, it had the supercharger on them,
That's
not the
what my buddy's
turbocharger.
gonna put on a car like mine.
Okay, now how does that air travel? Where does it go?
I don't know. I haven't ever looked at it.
This is what it does. It goes. Let me turn. There, stuff erased.
Oh, it's got an intercooler on it and everything.
Well, it does, but I want to know how it goes. All right, when you look at the motor, the supercharger is sitting on top of the motor, and it's got a pulley out here that's driving it, right? All right. Now, the motor's down here. Where you been? Where's Ryan?
I don't know around it.
All right, see this? There's Lawrence. That's it, he's dragging around. 7, 8, 9. Okay, now, what happens is the air comes through the air filter. It goes in the bottom of the supercharger. It goes out the top. It goes through the intercooler, and then it comes around here and goes into the engine. it goes in the bottom of the. If you look at this thing, you're thinking, yeah, this thing's grabbing that air and it's shoving it down in there. Well, on the old Thunderbird Super Coupe, it was going in the bottom, out the top, to the intercooler, out of the intercooler, and back around to the throttle line. And that's something. I mean, you would never think that was the way it was. You know, just looking at it, you got the idea this thing's grabbing air.
You can turn that supercharger any way you want.
Well, if you got the means to create your own plumbing,
Right.
yeah, you can do it. You put it where you want to. But the oil needs to be down there in the bottom. You see, see where I'm going with that? It's like it ain't like a chainsaw where you can just turn it upside down, you know, like that. All right. Now then, so let me see. Number 4 is D.
Number 5 is B.
The following statements are correct except A. Turbocharger bearings are usually lubricated with engine oil. That is true, is it not? It is true. B. The turbocharger drains power from the engine.
That's false.
Yeah, look at there. That is false. So it's actually using energy that would otherwise be wasted as it shoves the exhaust out there, right? And then the other two that are true is turbochargers resemble centrifugal superchargers, and turbochargers help convert more engine heat energy to mechanical power. Now, some superchargers, do you know why a 671 Detroit diesel has got a supercharger on it?
Detroit, that's
a diesel, big diesel engine now. You know why it's got? You know why it's got a? All of them have supercharger. You won't see one without a supercharger. You know,
Detroit?
yeah, the Detroit stuff.
Heavy load.
They got a blower on them. They have to have a blower on because they won't do nothing but idle without that blower.
Really?
Yeah, it's a 2-cycle diesel.
2-cycle diesel?
Yeah,
What do you mean 2-cycle?
it's got 4 valves in the top, and all of them are exhaust valves. And around the bottom of the liners is these holes. When the piston goes down below those holes, the supercharger blows air in those holes, and then it squeezes it, and then when it fires, it pushes out the exhaust. But what I'm saying is a 2-cycle. It's only got 2 strokes per cycle.
Right.
That's what the Detroit diesel engines. Now the newest ones may be different, but the ones they used for so many years had a blower on them because they wouldn't do anything except idle without a blower.
Do they have a turbo on it too?
Right. Some of them did. What they would do, now what I'm saying is they had the blower, and sometimes they'd have a belt-driven thing that looked like a turbocharger feeding it. Well, it's like a turbocharger, but it's driven by a belt.
Right.
You've seen those before. And they would have that feeding the supercharger, and then it would go on. So you'd have a little supercharger feeding a big supercharger, and then going on in
What
there.
about a cat engine? Same setup?
We were working on these 1271 Detroit engines in this workboat that we had down there where I used to work. And there was 3 of them in there. There had 3 of them big engines in there. You know, boats and airplanes always got bigger, lot more horsepower and everything than everybody else. You know, so they always use monster horsepower. And we had to replace a supercharger, a blower on one of them. And they had a supercharger feeding. It had a V12. It had 6-cylinder bells. This bank, 6-cylinder, that bank. 2 671 blowers and a supercharger feeding. You know, those things were monstrous, loud too if you were down there when they started them up. Okay, now then, turbocharger bearings. Well, let's see. 5 is B. He just right. How many internal wheels does a typical turbocharger have?
Talking about the
Internal wheels. How many internal wheels does it usually have?
2.
Usually got 2. Where are they?
One's at the front, one's at the back.
What if this thing's mounted sideways? One is in the, one's in intake, one's in exhaust, but they're both hooked to the same shaft.
Right.
And when the one in the exhaust spins, the one in the intake spins along with it. And so the faster the exhaust spins, the more it shows air in the intake,
Right.
unless the waste gate is letting it bypass, you see. All that,
What's
so.
the difference between a supercharger and a turbocharger?
Supercharger is actually driven by a belt. Turbocharger is driven by exhaust. Now, one time I worked on this little Escort that came out of the factory with a turbocharger on it. I'd never seen one before or since, but it was a factory turbocharger. Those cars were very, very rare. And I'd been working at the dealership for a long time, and I'd driven a lot of Escorts, you know. No, it was actually a 1.9, I believe. I mean, but we're talking in the mid-'80s. All right, so I'm, You know, a lot of escorts, you work on it, you get used to an escort, right? You don't drive the car stupid because, it's the customer's car. Got it? So I got on this little thing, and the way that it told you that it was getting boost was a little green light would come on the dash when it got boost. I mean, it didn't have a lot of bells and whistles, but when I looked at it, I said, we're going to put a Supercharger on an escort. It's the dumbest fool thing I ever seen. A little pancake-sized thing. It wasn't no bigger than that, But it was factory installed and all that. And so I got through with whatever I had. I don't even remember why I was working on it. But I took it on a short test drive. And I drove it the way I'd ordinarily drive an escort. And I took off in first, and when I hit second, pulling out onto the traffic circle over in Dothan, which is where I was working, that thing hit, when I hit second gear, and that green light popped on, and I got boost, that thing broke rubber, and it had fork steering. Everybody jerked me off the road. It scared me to death. I got here the tire, boy, it was just scooting. And I was thinking, wow. But that's the only one of those I ever saw, only one I ever worked on. And that thing just scared me. But I used to have an escort that would run out from under you. That's fine.
Oh, man, I would have
Yeah.
loved to do that.
I mean, I don't know. I mean, you look that up on the internet, you're probably thinking, turbocharged escort is probably going to be. I mean, they didn't make very many of them, I don't believe, because I didn't hardly see any except for that one. All right.
Turbocharger Regal out now.
Yeah. Well. Anyway, Technician A says the turbocharger turbine and compressor wheel are on the same rotating shaft. Now, he's right because I've already said that. Okay. The turbocharger turbine and compressor wheels are on the same rotating shaft. Now think about this. When you're talking about a turbine, when you're talking about a turbine, the turbine is actually driven by something, right? When you're talking about a turbine, it's going to be driven by something. If you're talking about a steam turbine in a power plant, it's driven by steam. If you're talking about the turbine in a torque converter on an automatic transmission, it's driven by fluid. You see? And so you've got your, what you got? You got your, what's the three elements of a torque converter? Can anybody remember that? Where's JT at? Sick for the second day in a row, right? All right. What you got there? What's the part? Remember the other part that's hooked to the motor that forms the case? That's the impeller. The impeller throws fluid against the turbine. The turbine spins the shaft going into the transmission. That's what drives the car down the road. Got that? Between those two is a stator. But one way or another, remember when you hear about a turbine, the turbine is being driven by something.
What happens if you don't put a torque converter on and you just put the transmission on?
It would stall as soon as you put it in gear. I mean, you got to have something. You know what I'm saying?
Won't tear it up.
Yeah, but now it is hooked up directly. Whenever your torque converter is locked up, you're hooked up directly. And what happens when you stop? It dies. Right? All right. So, anyway, Technician A says the turbine and compressor wheels are on the same shaft. Technician B says it's a good idea to change the oil in a turbocharged engine less frequently than a naturally aspirated engine. Less frequently. Technician A. That all, tell you something else, a lot of the times what they recommend is on these turbocharged engines that you don't just drive it like a regular car. They don't want you to drive it, switch it off, walk away. They want you to run it a while and let the turbocharger cool down.
I gotta get a turbo coming from work.
Yeah. So, yeah, it's not a bad idea. Which of the following is essential to long turbocharger life? Keep dirt particles and contamination out of intake and exhaust housings. I don't think that's very important. Do you?
Sure.
All right, now then, flush the turbocharger unit when the engine is overhauled. Got that? Maintain a clean supply of engine oil. All of these are correct. All of the statements describe oil coking except, what is oil coking?
I have no clue.
All right, now, have you seen this old baked crud that looks like, carbon, hard carbon, that's actually oil that has turned into carbon? You seen that before? That's what the oil coking is all about. Anytime you see coke, it looks like coal or something. Yeah. Huh?
That oil just can't do it.
Yeah, oil's then turned into something solid and it's black and ugly. When the engine is shut, the oil is shut down, the turbo has less resistance and will continue to spin without proper lubrication.
That's fine.
Coking can be reduced by using engine oil to cool the turbocharger. Or this happens when the camshaft is starved for oil, or oil flow to the turbocharger stops when the engine stops. All right, that's question number 9. C, it happens when the camshaft is starved for oil. One of the last places that oil goes, after it's gone everywhere else, is to the camshaft. Cam bearings and stuff. So if you got one that's starting to starve for oil, the cam bearings are usually wiped out. That's the first thing that's wiped out on there. The crank and the rod and the main bearings are they're carrying a heavier load, but they're always swimming in oil, and they usually have pressure. All right, atmospheric pressure at sea level, 14.7 psi equals what?
One more.
1 bar. 1 bar. That's why they talk about barometric, right? You got that? All right. So 1 bar. And I'll tell you this, if you use a European style fuel pressure gauge, it measures things in bar and millibars and all that. How many of you heard the weatherman talk about millibars when he's talking about hurricanes and all that?
I don't like the
Yeah, that's actually talking about air pressure is what it's talking about. And it never pays to be stupid, okay? Now then, right here, we're going to look at number 8, I'm sorry, engine performance 1, test 8. We're moving right along here. You notice since I had to give you 3 tests per, I could have made a 30-question test for each chapter because I got that many questions. But I was worried about Ryan because I'm afraid he's going to crash and burn, so I made every test. Y'all got him to think. Every test has got 10 questions, except some of them got 20 or 15 or something like that.
Thanks, man.
Ain't that right? Y'all probably give Ryan a pat on the back because Ryan's the reason y'all got 10-question tests. Ain't that right, Ryan? See, what I got to do is, as Ryan stays in here, I got to work Ryan up to 10, 15, 20 times he's leaving here. You have a 50-question test to do every week and every subject. That's right. Then he'll be on it. See?
You're going to hate semester exam.
Yeah, that's good, ain't it? Yeah, they got lots of questions on them. You know that.
Oh, that's not semester exam.
And they're open book.
They're open book.
All my end of all of them's open book. But what happens is if you get serious, and lots of times when I make a test for engine performance, no 2 people have the same test.
Yeah.
No 2 people have the same questions.
There won't be no clue.
They've all got, there ain't no copying. I mean, you got to look up your own questions. You know what's funny? When I told Ben Salter, I said, I told the class while Ben was sitting right there, and I said, everybody in here is going to have a totally different test without even the same questions on it. You know what Ben said? Oh, crap. What does this mean? He was wanting to copy somebody else's test. But really, he scored pretty good on those tests, and he worked his way through them. But this is one of the courses where I give everybody a totally different test because I got lots of questions I can give. All right. Which of the following, and this is engine performance 1, test 8, which of the following could result in low engine compression? Damaged piston or pistonry. Yep, damaged valve, damaged cylinder head gasket, all of the above. Let me ask you this. What if I was doing the compression test and I found out that on a 4-cylinder engine and they're numbered 1, 2, 3, 4, right? Or let's say I was on this one right here. Let's say I was on that motor right there. And let's say cylinders 4 and 6 both had low compression. I'm talking about really low compression, but all the rest of them had really good compression. 4 and 6 had really low compression, but all the rest of them had really good compression. I put oil in there and it didn't change anything.
Now it's one.
In both of them?
Well, it didn't change either one of them, did it?
What if the head gasket's blown in between cylinders? If the head gasket's blown between cylinders, there it just goes back and forth. See, got that? Think about that now. I want you to think mechanically.
That's what Ultima originally had wrong with it.
Number 2, when preparing for a compression test, Technician A disables the ignition system. Technician B only removes the spark plug for the cylinder he is testing. Who is correct?
Neither one of them.
Well, actually, you are supposed to disable the ignition system, but I'm going to tell you something I do, something I'm going to do. I'm going to shut off the fuel supply, too. Because you can unplug the ignition coil and it's still squirting gas in there, and that's going to affect your compression reading. So stop it from squirting gas and stop it from popping spark.
Well, I mean, would spark hurt it?
Spark wouldn't hurt as much as gas squirting in there.
Right.
I mean, basically. But what they're saying is you don't want it to start.
Right.
You know what I mean? If you're going to get a good cranking compression test, right? All right. So anyway, so what you're also supposed to do, you pull all the spark plugs out, you hold your gas pedal all the way to the floor, except, well, let me say something briefly right now. This is engine performance. You know these electronic throttle bodies, it's got a motor on the side of the throttle body? Mm-hmm. Do not take your finger and open that throttle plate with your finger.
Why not?
Because on some cars, you'll be buying a throttle body. On some of them. And I'm talking about if it's got that electric motor in there.
Right.
My buddy Donnie over there was working on a Nissan or some Asian car, and he on Fords, he'd been used to pushing it open with his finger, and it didn't hurt a dadgum thing. Well, on these Nissan cars, first time he did that, one of them, the throttle body was dead in the water, and he had to buy a throttle body, and it was fairly expensive.
Yeah, probably about 300.
So you turn on the key, you mash the gas pedal, let the PCM open the throttle plate. Don't open it with your hand, okay? But let the PCM, because you can't open it, you ain't on the one with a cable, you can open it with your hand, right?
Yeah.
But if it's electronic throttle body, don't force in gears by moving that thing in your hand, you mess it up sometimes. It's best to just keep that as a rule of thumb, is always use the gas pedal to open the throttle plate. That way you don't get in trouble by trying to remember which ones you can do it on and which ones you can't. See what I'm saying? Because if it comes out, if you got to go tell your service manager, hey, I destroyed the throttle body on this car because I was an idiot, you know, he's not going to be happy because that's coming out of the profit, you know, that the shop would have made. All right. Unless he's going to be, crappy and charge the customer for something that the mechanic tore up, you know. All right. Now then, so you always remove all the plugs, hold the gas pedal all the way to the floor, disable the ignition and the fuel. Now, the good thing about holding the gas pedal all the way to the floor on a fuel injection engine is it shuts off the fuel injectors. The fuel injectors are shut off at wide open throttle when you're spinning the motor. And I used to tell them guys, I said, and I showed my nephew this on his Jeep that he was driving. I said, watch this, John. They hold the gas pedal all the way to the floor. Unless there's some gas puddled up in there that it pulls in and causes the engine to start, it'll go. And I said, now watch this. You don't impress your girlfriend. You know, and John don't know a whole lot about cars because he's, going to something else. I said, push that gas pedal forward. Listen to what it's like. Yeah, spin it over. And I said, then you get out of the car and say, yeah, I've seen this before. And you get down there and you act like you're doing something. And then you get back in there and you go, boom, and she's impressed. Girls are impressed if you can fix a car. You know what I mean? Anyway, that's just, you play a little joke. But the funny thing about it is you can keep it from starting if you decide to. But be careful with that because if there's gas puddled up, it'll pull it in there, and if it goes above 400 RPM, but that's the clear flood mode. It thinks the plugs are wet and you're trying to dry them off.
Okay, here I have a question about that. How come? Okay, the rotary engines. You crank them up, drive them across the yard, shut them off. They're flooded.
It works. It does.
And you holding it to the floor will not clear the flood.
Yes, it will.
No, you actually have to pull the fuel relay.
No, not on RX-7 you don't.
RX-8 did. RX-8 you have to actually pull the fuel pump relay and the plug.
RX-7 you hold it to the floor and it'll stop it.
There's a diagram over how a rotary engine works.
Actually, I found a video on YouTube that
works real smooth. Yeah, I got a video that we watch in CDX video too. But how many compression strokes should be used during a compression test?
I think it's 3.
I like to do. And what you saying? Number 3. It says 4. I like to do 6. I like for it to go, puff, 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 puff. Let's make sure we get enough. All right. Sometimes you'll have a compression gauge that's not holding the pressure, and the needle will bounce back and forth. That's not a problem with the engine. That's the little Schrader valve at the bottom of the compressor gauge contaminated or got a piece of dirt in it or something. But you got to have a good solid operational compression gauge. When performing a cylinder leakage test, the following statements are true, except, all right, number 1 would be bubbles in the coolant may indicate a defective head gasket. Shop air should be applied through the spark plug hole. Air hurt escaping through the tailpipe may indicate a defective exhaust valve, or shop air should be applied to the dipstick tube. Yeah, number 4, you're not going to supply shop air to the dipstick tube. The cylinder leakage test is not going to put very much air in that cylinder. But I did have a video that I put online that's had like 60,000 views on YouTube, where we were out here in the shop and we had an overheating Sebring that had a 4-cylinder in it. And we took the thermostat out, which is right under the radiator cap. You pull the radiator cap neck off, you pull the thermostat out, put it back on, fill the coolant system all the way up, just all as high as you can fill it up, right up there at the very top. And you take all the plugs out, and except one. You put number 1 plug in there, you spin it, bounces while you're spinning the engine over, you got compression leaking into that water jacket. Right. If it don't bounce, you move that plug to the next hole, spin it again, move it to the next hole, spin it again. When we got to the 3rd hole on the one that we were doing on that video, if I remember right, it was number 3, it was just bouncing and pushing bubbles out and all that. We knew right then that car had a blown head gasket.
And didn't somebody get covered in coolant, if I'm not mistaken?
Not on that one. Not on that one. I mean, that was there was another one where it blew out of her. Well, there was an Escort that blew a head gasket so bad that the guy said, it's running hot, we think we've blown a head gasket, and he dragged it up here. And the radiator neck's kind of pointing back, which is smart because it's pointing back away from whoever's taking it off. So if you take it off and it's hot, it's going to go that way instead of out on you. Right. See, some of them were pointing to the side years ago. Somebody stand there and do this and it all over them. Well, on that Escort, they pointed it back toward the car, so it might, get your hand or something, but it ain't going to get your whole body. Anyway, took the radiator cap off, spun it over. First time a compression stroke came up, it fire hose water out of there all over everything. I mean, it was like this big of a,
head gasket was messed up?
Yeah, head gasket blown
No,
up.
what was the video we took on that Nissan to see when it shot the coolant out?
Yeah, we took a video of it shooting coolant out, but I don't remember what the details were.
It was trying to figure out which cylinder was hydraulic.
Yeah, but perform. All right, so number 4 you said was D, shop air should be applied to the dipstick tube. That is not correct. However, listen to this, guys. Stop up your PCV, stop up your crankcase closure tube, put 15 pounds of air pressure on the dipstick tube, and go with your soap bottle looking for your oil leak. Works just fine.
Does it really?
15 pounds of air pressure. If it's a pressure leak from under a head gasket or something, you're not going to find it that way. But if it's an oil leak coming from the oil pan or something, or a valve cover, you can spray soap bubbles, and it'll make bubbles where the oil leak is, because that air is going to be 15 pounds more in the crankcase than you got out here. It's not enough to blow the seals, you see, but it is enough to where you can locate the oil. That's for checking an oil leak. That's not a cylinder leakage test.
You're a smart man, you know that, Mr.
Yeah, well, I just picked up some things here and there. I didn't come up with that. To perform a cylinder leakage test, Technician A says 20% leakage is acceptable.
True.
Technician B says a cylinder will show too much leakage if the piston is not at TDC on its compression stroke. Who is correct? Y'all happy about that? Everybody like that? Well, I was looking for my phone. I couldn't find it. It's laying right up there. All right. So number 5 is going to be a C. That's going to be both of them. A cylinder power balance test is performed. Cylinders 1, 2, and 3 all drop 175 RPM, 175, when disabled with a scan tool. Cylinder 4 drops 50 RPM when disabled. The following statements are correct, except cylinder 4 is much weaker than 1, 2, and 3. Is that one right? There may be a mechanical problem with cylinder 4. The test could also be conducted by grounding the plug wire for each cylinder. And number 4 is much stronger than 1, 2, and 3. That one is the one that's wrong. There was a Mustang that was over there, and I usually in one of my engine repair classes I pass out a little.
D, right?
That's going to be a D. Yeah, 6 is D. There was a Mustang that had a PO20 something code, PO303 or 304 or something. I can't remember what cylinder it was. Over there, and Marty was working on it. He's a shop foreman at Bundy's now over in Dothan. And so Donnie started out working on it because it would it didn't run bad, but it would throw this 303 code. I guess we're going to call that cylinder. I don't remember which cylinder it was. And he looked at the injector, and he looked at the ignition, and he looked at other things, and so never did find anything. He'd clear the code and drive it, and the code it kept coming back. The code kept popping back on. So he did a power balance test using a worldwide diagnostic system, which basically gives you a track of how much, how the RPM is balanced between cylinders, and if one of them's low, it'll make a shadow track on that one. And number 3, the one that was in question, had 40 RPM less. In other words, the engine was slowing down 40 RPM slower while that one was supposed to be firing. You see? And so he checked the compression, and the compression was, it's interesting, all these 40s was 40 pounds lower on that cylinder than it was the rest of them. Isn't that interesting? So it wasn't valves, did a cylinder leakage test, and there was no cylinder leakage anywhere, not in the crankcase, not till they passed the piston. So they pull the head off, and when they turn the engine over with, barring it over with on the crankshaft bolt, the number 3, the one that was given us, it was that much lower than the rest of them, because at some time they had ingested some water that went in that cylinder, and it bent the rod a little bit. But everything was running real smooth, but it was just throwing a misfire. Now, if it hadn't had OBD2 and misfire detection, you'd have never known that car had a problem, because it ran great. See, but it was picking up on that.
The computers in some of the older Mustangs are pretty much stupid. Like, you throw a big motor in there and it'll just confuse it, and it'll set itself right. Why is that?
Well, it won't set itself right. If you've got a 302 and you put a big block in there, it's not going to run right. Now, there is some adaptive learning that can take place, but if you've got 14-pound injectors in this one, and 30-pound injectors in that one, you're going to have issues. I mean, it's not as simple as plug and play. You know what I'm saying? This ain't like a video game.
What he's talking about is a 302 block board out to a 347.
Yeah. Well, that's not, if you're not making a lot of difference in it, it's probably going to do some learning. Now, you're probably going to see some fuel trim stuff going on.
Pretty much just a bigger piston, right?
And all that.
Cam, everything.
Yes.
Yeah, everything's bigger. But Anyway, that's some of that hot rod stuff in which we don't deal in here. Okay, now then we don't have time for that. You know what I'm saying? We don't have. I mean, everybody's interested in hot rods. That's what you do at the house when you're doing hobbies. Here we fix people's cars and we make money. Now that's why I told you the difference between hot rod work and mechanic work is hot rod work, money's flowing out. Mechanic work is flowing in. You making money and putting it in your bank account when you're doing mechanic work. Whenever you're doing hot rod or hobby work, the money's flowing out of your checking account into your hot rod. Usually a lot of money flows out into your, and that's okay if that's what you want to spend it on. I ain't saying it's a bad thing, but I don't have time to fool with it in here. All right, let's see. You got that? Technician A says, removing the plug wire from a spark plug while the engine is running could damage ignition system components. Is he right? Everybody does that, but it's really not a good idea to do it very much on a customer car because that spark is looking for somewhere to go. And if it goes somewhere where you don't want it to go and it damages something electronic, then somebody's going to have to buy that. No, that's not typically a problem. If it shocks you, it ain't a big deal. Okay. Actually, you don't want it stopping your heart, so be careful not to get shocked. The way you can do this, if you're using your hand for that and you just absolutely don't want to get shocked, is you can take something like my power balance armband, which I got somewhere here in one of my pockets or whatever, and put it around here. I mean, wrap a piece of wire around it so it's touching your arm and hook an alligator clip to the ground. And if it does jump and hit your hand, it'll go through that wire to ground. It won't come through here. You won't feel all of this up here, you know. But, you know, it may hit your finger. Now, one time I was working on a Bronco 2. I was working on a Bronco 2, and I was pulling the car wire back, you know, to see if it would. And I had my hand laying on the bracket right there so that if it did hit me, all it would hit was my hand, you know. And when I pulled it out, I pulled the car wire out, and the spark came out there and found my thumb, you know. Pow! You know, I just did about like that because all it was, you know, it doesn't hurt a whole lot if all it hits is your thumb and it goes right in the ground. See, because all this is going through a little bit of. But Philip Kirkland, this guy that I was working with, didn't like getting shocked. Man, I thought he was going to throw up. When he saw that thing hit my thumb, you know, and our shop foreman says, hand me a screwdriver one day, and I just grabbed one in my box and handed it to him. He's checking spark down there, and I didn't pay no mind to the screwdriver that I gave him was the one with the crack in the handle, and I saw that spark go through that crack and back. All right, but anyway, it's not a good thing to horse around with that spark because it can kill you, especially on a new ignition system that's popping 100 and something thousand volts, you know. Nothing to toy around with, you know.
Go work on one of those.
Yep. All right. Now then. Technician A says removing a spark plug wire from a spark plug while the engine's running could damage ignition system components. Technician B says grounding a spark plug wire while the engine's running could damage ignition system component. Who is correct? That's A. B is wrong. You're not going to damage nothing by grounding the spark plug wire. That's one of the reasons I say if you take a Tesla and you're real gentle about it, and you hook it to ground, and you back probe without tearing the boot or going through the wire, you very gently back probe that wire until you get in there and let the spark jump through the test light bulb. You kill the cylinder that way, you're not hurting the dadgum thing. And you ain't going to get shocked that way. See, that's the best way to do it. If you can unplug injectors, that's even better. Because you ain't going to get shocked by an injector. Unless it's the Power Stroke diesel, the older one has got 115 volts, it may knock the tar out of you, so be careful about it too. Which is not a step in the cranking vacuum test. A, crank the engine while observing the vacuum gauge. I'd say that's a step in the cranking vacuum test. Connect the vacuum gauge to a source of manifold vacuum. That is also another. Block the throttle wide open. Yeah. Of course, you're supposed to disable the ignition or fuel injection. I like to disable the fuel injection anyway because I don't like that gas spread in there washing them cylinder walls down because it can cause your, your lubrication to go away. Have you ever seen an engine, a truck, somebody gets his truck that they dragged out of a barn, it's been setting up for 6-8 months because somebody couldn't figure out what was wrong with it, and you're spinning it over, and maybe they tried to start it a lot and they never would get started, they gave up on it, and you're spinning it over, and Derek's done this. Derek works on cars all the time. Derek, if you ever notice when Derek eats lunch, he drinks motor oil for lunch. Anyway, so if you spin the thing over, it's going rah. You ever have it real slow? Then when you finally bust it off and get it started, it's used to starting every day, it spins good and fast and snappy. You notice that? The reason it does that is washed the cylinder walls down and them rings are dragging on dry metal, and it's hard for it to move them. All right. Now on the newer ones with them low tension rings that are real skinny, It just acts like it ain't got no compression. Yeah. When the cylinder walls are washed down. Shoot a little oil in every cylinder and it starts, having compression to bust off. Normal engine vacuum at idle is A, 3 psi, B, 120 inches of mercury, C, 17 to 21 inches of mercury, or D, 3 to 6 inches of mercury. Now listen, on that Chevrolet truck we worked on, what was the vacuum when we first started? You remember? We're measuring it in inches of mercury. It was about 12 or 13.
Like 12.
That's right. Then we got it, put a timing chain in it, and it went up to about 16, which was better, but still not right. And after we adjusted the valves up between 19 and 20. See what I'm saying? So you get an idea. Burn that in, guys. You're supposed to have 18 to 22. But they say 17 to 21. An inch or so either way. On your vacuum gauge, where the green is.
Yeah.
How many of you have ever seen a car with a vacuum gauge on the dash, built from the factory?
A boost gauge?
No, a vacuum gauge.
I've never seen one of those.
They used to put them on there long years ago. Chrysler used to have the turn signal indicators out there on the fender, looking back at you. When you turned on the turn signal, the indicator on the fender would blink, and you would see that out there. Wouldn't have it. Some of them would have it on the dash and on the fender. Well, some of the Plymouths, to one of the turn signals, had a vacuum sensor hooked to it so that it would ground that light on the fender out there when you were really into it real deep and your manual engine vacuum was low. And if you would drive it and keep that light from coming on, you'd get better gas mileage. On the vacuum gauge on the dash, if you kept it in the green most of the time, you'd get better gas mileage. You see, but 65 Chevrolet SS, Impala, the hot rod one, it had a vacuum gauge on the dash for that reason. I asked my daddy when I was a boy, I seen this vacuum gauge on the dash on a car like that. And Daddy was a mechanic. He had a shop for years and years and years. And I said, Daddy, what is a vacuum gauge good for on a car? Because I didn't have a clue at the time. He said, that's something you look at while you're having a wreck. If you're watching that gauge too close, bam, you run into something. That's what he's talking about. And I asked this guy that had this car, he had his first car he got, he's Alan Waters over at the high school over there. He had one of those. And I said, Alan, that gauge on your dash, what's that do there? He goes, I don't know, it moves around all the time, but I ain't got no idea what it's for. And it was his car. Technician A says, a low but steady vacuum idle reading indicates a sticking valve. That's wrong. Technician B says, fluctuating vacuum gauge reading shows incorrect ignition timing. Who's correct about that? Neither one of them. That's a dog. What three things can cause low end vacuum?
Timing?
Timing's one. Ignition timing. What else?
Valve.
Huh?
Valve out of adjustment.
Valve timing. Well, valve's out of adjustment, but valve timing, which is sort of a like valve adjustment. Valve timing, ignition timing, EGR. If EGR is flowing, you're going to have low vacuum. Remember that at idle. So if you ever see low vacuum at idle and it's running like crap, make sure the EGR is not flowing. If you crank that thing up and it ain't been running but a minute and the manifold's starting to get blistering hot, EGR is flowing. And I don't know how many times I've had people say, this thing runs like crap, we don't know what to do with it. And I feel the intake right after we started it when it had been sitting there 4 hours, it started getting hot. I see you got EGR flowing. It has to be. Unplug the EGR valve or whatever, run smooth as silk. All right, now then we got on this one here, engine performance test 9, test 9. All of these could cause a high starter current draw except defective ignition switch, worn starter bushings, low battery voltage, shorted or grounded starter wiring. Come on, guys, don't be dumb on me. A defective ignition switch is not going to cause high starter current draw. There ain't no way it can. It's totally different. That is a totally different circuit. Got that? That's going to be an A. Technician A says current must be flowing in a circuit to test voltage drop. You guys ought to all know that because there's a voltage drop worksheet gave out. Technician B says voltage drop can be greater than source voltage. Oh, that guy doesn't know anything he's talking about, does he? So number 2 is, all right, no, that's going to be A. 2 is A. Yeah, because the current has to be flowing. If you're going to be checking voltage drop, you better be spinning your starter, running your fuel pump, or whatever. Technician A says if a positive battery cable is hot, not enough current is flowing. If a positive battery cable is hot, you're holding your hand on this cable, right, and it's getting hot. Technician B says every manufacturer recommend battery cable replacement rather than repairing the damaged cable ends.
I wouldn't do that.
Technician A says if a positive battery cable is hot, not enough current is flowing. Now, why is that? Technician A is the guy that's right on that. You got some resistance there, guys. That cable's getting some, it's got resistance and it's slowing the current down. Where you got resistance, you got heat, okay? Technician A says if a positive battery cable is hot and not enough current, excuse me, I got the wrong question up there. Never mind. Technician A says if starter drive clearance is too small, the starter will produce a noise during cranking. Technician B says if starter drive clearance is too large, the starter will produce a noise after cranking. Both of those guys have it backwards. Because if it's too close, it's gonna, the gear's gonna stay in there, and it's gonna be, when you let off.
Yeah.
But on these Chevrolets that had the shim between the starter and the block, you've seen them. Now, what a lot of people do is they just take the same shim that was there and they put it back. Is that what you do, Derek? Now, what happened with Alan Cobb's father-in-law, Felix, was working on it was Alan's wife's sister's son was staying over here with Alan and his wife for a while. And he had a little Chevrolet, and his grandfather put a starter on it, and he did what you're talking about. He put the same, why does it even have a shim to start with? Let me see that starter right there. Bring me that starter. Yeah. You get that starter working where you can bench test it? Check it right, amateurs. All right. Actually, you see where it bolts up right here. You got, let me make sure I hold it. You got a shim between here and the block. See that? And that is actually, because of the fact that not all starters are machined the same, you have to have a shim that is the right for that particular starter. Right. If you just pop the same one back in there, which is what Alan Cobb's, wife's dad did, it barely was catching the flywheel, and it chewed the teeth off of one side of the flywheel. Not good. If it don't sound right, you better go back in there and revisit. You're supposed to have a certain amount of, like a paper clip, between the bottom of that tooth if you can get in there. Sometimes you can't get to it. But what you got to do, something else that we used to do that was a trick, was if we put a washer under this side, what does that do? That makes his starter drive closer. If we put a washer under that side, it makes it farther away. So you can just use one washer if you had to set that.
It's hard to do them shims, and especially if it's a long one that go all the way across.
Yeah, of course it's got a slotted on one side, But one way or another, that's what that's about. And that thing there was about one part in my hand.
Yeah, I have it together.
All right, so those guys got it backwards. Number 4 is dog. Technician A says manufacturers sometimes use metal shims to provide accurate starter drive clearance. That's what I was just talking about. Technician B says hitting a starter motor may damage the permanent magnets inside. If you whack it, let's see, somewhere in here. That's not a bad idea as long as you don't hit it too hard. See this magnet right here? This magnet right here, this is a power window motor, and it's a permanent magnet motor. That magnet is ceramic. And if I hit that thing with a steel hammer too hard, it's liable to crack that magnet, and then your starter's junk anyway. But you can tap it and you're not going to hurt it. I would hit it back there close to the back of it, not on the side of the starter, but close to that plate on the back of the starter. Just tap it kind of gently. If you have to just knock the crap out of it, you're probably not going to go there. It shouldn't take but just a tap to get that thing spinning. And what happens is the brushes that ride against this commutator go to sleep and get to where they barely are touching. Fuel pumps fail that way. All these fan motors, everything fails that way. And brushes get to where they wore out to the point where they barely are touching. Well, if you whack it, it jars them, and then it starts spinning. And they can. And while it's jittering, it's going to stay there running. That's how that goes. Anybody know what this is?
I can't see it. Piece of plastic.
This is a voltage regulator from an old GM alternator. Internal voltage regulator from a GM alternator like in the mid-70s. Yeah, mid-70s. Did you know they had something that little in the mid-70s that was a voltage regulator? They did on that one. That's a trivia question. What is this right here?
Injector.
Okay. What is this right here?
I can't see it. Like a battery.
Exactly, camera battery. Got nothing to do with it. Did I mess you up or what? This right here is the evaporative test port. And that's what I was telling you. We put that Schrader valve back in that one the other day?
Yeah.
Yeah. The Schrader valve in this right here is left-hand thread. And this green one that you check your evaporative system with, left-hand thread Schrader valve. Remember that when you screw it out of there. You know that light went off and never came back on? We fixed it, didn't we? All right. So, got other goodies in here too. I bet nobody in here can tell me what this is.
No, it's like a igniter.
Huh?
It's like
He's sharp. It's an igniter for what?
I don't know.
It's for a Nissan.
For Nissan?
Yeah, it's an igniter for. It's actually a transistor, and you bolt it down here to something with some grease under it so it don't hot. And you got it's a power ground. You got actually it's a NPN transistor is what it is, and you got the ground coming in, ground going out your coil, and every time the PCM fizz a positive pulse into that middle terminal, bap 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 fires a coil. That's what that is. It's an igniter. Always remember that. And we have spark plugs and other stuff down in here. All right. All right. Now we got to go. I found that up and had people claim it was a throttle position sensor. Kind of looks like one.
Oh, really?
All right. What number were we on?
6.
Technician A says manufacturers sometimes use metal shim. Never. Well, they do. No, 5 is actually going to be C. That's going to be both of them. In which component of an alternator is an electrical current induced? In which component of an alternator is electrical current induced? Permanent magnet? Does an alternator have a permanent magnet in it? No, it does not. Because we want to be able to control that magnetism, right? Is it the stator?
Yeah.
The electrical current is induced in the stator. That's the winding around the outside, okay? Now the rotor is the magnetism that's actually creating the electrical current as that magnetism sweeps across the stator windings. And then the reluctor is what? In a electronic ignition, the reluctor spins next to that magnet. So I guess those little claw teeth on here could be called the reluctor on that alternator if somebody wanted to call it that, but that did not typically used for that. How many phases of AC electrical current are generated at an alternator stator? How many phases of AC electrical current are generated in the alternator stator? Some of y'all ought to know that.
3.
Has to be 3. Has to be 3. Technician A says the battery must be in good condition and at least 75% charged to accurately test an alternator. Technician B says alternator output should be tested at idle. Who is correct?
I think it's A.
No,
B.
A is right.
What?
A is right. You can test it at idle, but you're going to do better revving it up a little bit. Technician A says if an alternator voltage output rises and then falls as engine speed is held at 2,000 RPM, a drive belt may be slipping. Technician B says it uses a scan tool to observe charging system voltage. Wow, he's correct about that. Would you use a scan tool to observe charging system voltage? Why not? It's going to give you the voltage. Well, no, voltage. Charging system voltage would actually be what the charging system's doing. And a scan tool is going to have that. That's not bad information. So number 9 is going to be a C. What alternator components are responsible for converting AC to DC output? Diodes. And you'll see some of these old timers, for some reason they can't say diode, they say diode. They stop.
Sitting hiding my butt.
All right, is everybody happy with that little session there?